Welcome, deep divers. When you look at a building, whether it's a gleaming skyscraper or just the walls of your own home, have you ever really paused to consider the story behind it?
It's a great question because there's always more than meets the eye.
Exactly. Beyond the blueprints, the budgets, and the sheer physicality of concrete and steel, there's this intricate, deeply human drama that brings every structure to life. Because really, construction isn't just about materials, is it? It's about people.
It's absolutely true. Every building, from ancient wonders to the house down the street, it stands as a testament to this incredible interplay of human vision, skilled craft, and the often challenging practical realities that push us and the project every step of the way.
What truly fascinates me is how those elements intertwine. The vision, the hands-on work, the money, the personality.
Right. It's a complex mix.
And that's exactly what we're diving into today. Our mission is to explore that complex, profoundly human process of creating a building. We'll uncover the surprising facts, the inherent tensions, and the vital importance of human elements like communication, trust, and even that emotional labor you hear about that shapes every construction endeavor.
Yeah, that emotional labor piece is huge, especially when things get tense.
For sure. Our goal is to offer you a shortcut, really, to being truly well-informed about those often hidden layers of building, transforming raw materials into places where we live, work, and, dream.
And our deep dive today draws insights from all over the place. The rich historical evolution of architecture, modern project management strategies, the actual science behind the materials we use, and the critical role of building codes.
But we have a special lens for today, don't we?
We do. At the heart of our discussion, we'll be using a unique, really intimate lens, Tracy Kidder's classic book, House. It gives us this amazing anecdotal glimpse into the relational dynamics of building just one single-family home.
It's such a great read for capturing that human element.
It really is. It captures the hopes, the conflicts, the compromises that unfold when you have, say, an idealistic architect, proud, maybe old-school builders, and well-meaning but sometimes naive clients all coming together.
It's like a microcosm of the entire construction industry, isn't it? Played out on the scale of one family's dream.
Exactly. It shows those tensions, those cultural and class divides sometimes between the world of design and the world of the trades.
So prepare to connect ancient wisdom with contemporary innovation and maybe gain a powerful appreciation for the immense human effort and coordination involved in creating the built world around us. Let's start at the very beginning, shall we? So, okay,
Sure.
someone has that initial spark, that idea for a building. What's the very first, most crucial step in turning that into like a real project? What do they really need to define before anything else happens?
Well, it goes way beyond just sketching something on a napkin or saying, I want a new house. You have to think of it less as a simple desire and more as a foundational strategy.
Strategy.
Yeah. Every successful project, whether it's a garden shed or a massive skyscraper, it starts with a really clearly articulated vision of its purpose and what it's meant to achieve. What is this thing for?
And that purpose, it's not just set in stone right at the start.
Not at all. That's crucial. It's constantly revisited, assessed, updated throughout the entire project lifecycle. It acts like a compass, guiding the team. The PMBOK guide really highlights this iterative assessment.
So it's not enough just to imagine, say, a beautiful living room. You need to articulate the value that living room or the whole building is supposed to deliver.
Precisely. That initial definition has to encompass what project management calls business value. Now, that could be easily quantifiable, like, increased property value or lower energy bills.
Or it could be more intangible.
Exactly, like creating a stronger community hub, or for a home, maybe just a better quality of life for the family living there. And if that fundamental alignment between the building and its intended purpose ever gets lost, or if that value it's supposed to deliver seems unlikely to actually materialize,
Then what?
well, an organization or even an individual client might choose to terminate the effort, just stop the project. It really underscores how vital that initial clarity, that alignment with need truly is.
Wow, okay. That makes a lot of sense. So looking back through history, can we see examples where this initial purpose was just so incredibly clear, so defined, that it really dictated everything about the build?
Oh, absolutely. Think about the rigorous planning behind historical places, like the pyramids of Cheops. The stated purpose was profoundly funerary. It was all about the afterlife.
Right, not exactly a multi-use development.
Not at all. It was for the sustenance of the royal body that lay beyond, in the heart of its stone mountain, as one history puts it. This This singular, clear initial purpose guided every single subsequent action: the colossal scale, the complex inner chambers, the materials, the labor force. There's absolutely no ambiguity in its mission.
So the takeaway for us, maybe, is that next time you walk into any building, even just a simple house, remember it didn't just happen. It started as a deeply considered intention, a purpose. And that purpose, in its own silent way, shaped every single detail you see, and probably countless details you don't.
It's purpose-built, fundamentally. Even if that purpose is simply a place for this family to live and grow, that's still a powerful guiding principle.
Okay, so we have that core vision, that purpose. Now the architect steps onto the scene, and their role, it's so much more than just drawing pretty pictures, right?
Oh, absolutely. Architectural design is this incredible synthesis, this delicate balance, really, of artistic expression, functional necessity, and a deep responsiveness to its context, its environment.
Yeah.
And it's a role that has evolved quite a bit through history.
Yeah, I was going to ask about that. We often think of architects today as, primarily designers, maybe separate from the actual hands-on building, but that wasn't always the case.
Not at all. If you look back at early architects, like the famous Andrea Palladio in Renaissance Italy, many were trained as both sculptors and stonemasons.
Really? So they were designers and builders.
In essence, yes. This gave them an innate, profound understanding of materials and craft, which was intrinsically integrated into their design philosophy. They weren't just conceptualizing in the abstract, they understood the very texture, the weight, the behavior of the stone or brick they were specifying.
That's a huge difference from, say, how we often perceive the role today. A Palladian architect would design, but also know exactly how the stone needed to be cut, how the brick would behave under load.
It really is a different model, and this deep understanding allowed for a kind of pragmatic adaptation of vision to the available resources. While Palladio created these incredibly grand, influential designs, historical accounts show they were often executed with, quote, cheap material, brick faced with stucco instead of stone, when necessary.
So adapting the grand vision to the reality of the budget or material availability.
Exactly. That tension between the ideal vision and the practical available resources, that's something designers still navigate constantly today. It's a perennial challenge.
Beyond the practicalities, though, what about the philosophy behind architectural vision? I mean, someone like Frank Lloyd Wright must have had some really strong feelings about what constitutes truly good design beyond just function.
Oh, indeed. Frank Lloyd Wright, if you read his autobiography, he was quite critical of conventional architectural education of his time. He strongly advocated for approaches that foster independent thought, creativity, and a deeper understanding of the principles of design and nature.
So less about just learning rules, more about deep principles.
For him, yes. True architectural vision required this holistic engagement with the world, not just technical rules, but a real understanding of context, materials, and human experience. Similarly, you have someone like Le Corbusier, a giant of modernism, who famously argued that architecture has nothing to do with various styles.
Styles are irrelevant.
To him, yes, in a fundamental sense. He argued architecture dealt with graver ends, things like geometry and mathematics, which he believed impressed the most brutal instincts by its objectivity. He was after something more universal, more fundamental than surface appearance.
So it's less about fleeting trends or, aesthetics for aesthetics' sake, and more about finding these fundamental principles that resonate deeply and universally. Can we see that in historical examples? Like abstract but really impactful design.
The Greek Doric order is a perfect example, often cited in architectural history. It's described as an ideal invention, a pure creation of the mind that achieved this profound harmony.
And it wasn't just copying wooden structures in stone.
No, that's the key point historians make. It didn't simply mimic existing timber forms. It was an abstract design, born from deep thought about structure, light, proportion, and order. It really embodies those fundamental geometric principles Le Corbusier was championing centuries later.
This really invites you, the listener, to look at buildings differently. Not just as pretty facades, maybe, but as expressions of these deeply considered ideas shaped by centuries of thought about how we humans interact with our constructed world. It's like a tangible philosophy etched in stone or steel. #C. The challenge of sight and environment.
And building on that thought, no matter how profound or abstract the architectural vision is, it always has to contend with the physical world it occupies. The building site and its environment, the climate, the topography, the soil, they are far more than just a backdrop.
Right, they're active participants.
Exactly. They are fundamental determinants of architectural form and construction strategy, demanding really careful consideration from the very earliest stages.
I can imagine that was especially true in ancient times, and they didn't have, the massive earth-moving equipment we take for granted today. They had to work with the land more.
Absolutely. Think of historical examples like the city of Pergamon, an ancient Greek city in what is now Turkey. Accounts describe it as a calculated work of urban design.
Calculated how?
Well, the public buildings were intentionally framed with porticos and platforms, strategically using local materials like volcanic andesite and marble. Most of the city was meticulously contrived. They manipulated the landscape quite deliberately to fit the architectural vision.
Not always.
Interestingly, no. The exception noted by historians was the theater. That structure was largely allowed to accept the precipitous land just as it was. So it highlights this very deliberate choice architects and planners face. Do you manipulate the site to fit the design, or do you adapt the design to fit the site? Or maybe a bit of both.
So they weren't just dropping buildings onto a plot. They were actively sculpting the entire urban fabric, sometimes around the natural contours, sometimes reshaping them. What about modern concerns, especially with climate change being such a huge, pressing issue now?
Yeah, this raises a crucial question for today's architects and builders. How do we design responsibly and sustainably now in sustainable construction practices? There's a really strong emphasis on considering ecosystems, the forgotten resource.
The forgotten resource. What does that mean practically?
It means advocating for designs that are responsive and anticipatory, especially looking at future climate impacts. It involves actively integrating natural systems for services like, say, waste processing or stormwater retention.
Like the building becoming part of the ecosystem.
Precisely. A well-known example is the Lewis Center for Environmental Studies at Oberlin College, which uses something called a living machine, essentially a contained wetland ecosystem to process its own wastewater on site.
That's a powerful idea, turning the building itself into part of the ecological solution, not just minimizing its negative impact. Can you give some very practical, maybe more everyday examples of how the environment dictates specific design and construction choices, even for just a single home?
Absolutely. For instance, there are builder's guides specifically for different climate zones, like hot, dry, and mixed dry climates. These guides get incredibly specific. Well, they detail the need for things like large overhangs to protect exterior walls from direct sun and rain. They stress ensuring drainage plane continuity at window and door openings, basically, making sure water hitting the wall has a clear path down and out, preventing intrusion.
Stuff you might not even notice, but it's critical.
Totally critical. The guides also warn against specific problems like slab moisture problems that can be caused by irrigated plantings too close to the house perimeter. The water wicks under the slab. Even something as technical as the mean monthly outdoor dew point temperature influences crucial construction choices.
Wow, down to the dew point.
Yes, because that affects where condensation might form. So it influences decisions about where to locate mechanical equipment and ductwork, ideally not in exterior walls or vented attics in certain climates, to prevent moisture issues and energy loss.
It really hammers home that the environment isn't just a passive backdrop for a building. It's an active participant in the design process. It dictates these critical decisions that profoundly affect a building's performance, its comfort, its durability, its longevity. It makes the building resilient against both time and the elements. Okay, so we've nailed down the vision, we've wrestled with the site and environment. Now, how do we actually share these complex ideas? How do we communicate the design precisely to everyone who needs to understand it to actually build it? We've certainly moved a long, long way from just, pen and paper blueprints.
Indeed, we have. The methods for articulating and sharing design information have transformed dramatically, leading to, frankly, unprecedented levels of precision and integration in modern construction.
And the big buzzword here is BIM, right? Building Information Modeling.
That's the one. BIM platforms represent a really significant leap forward. They're not just creating, say, a 3D model that looks nice. They're generating comprehensive data for multiple uses that go far beyond simple geometry and material layout.
Data like what?
We're talking about data for structural analysis, energy performance simulations, detailed construction scheduling, and even generating specialized fabrication models for things like ductwork or steel structures directly from the central model.
So it's not just a digital drawing. It's more like a smart, integrated database for the entire project. Everyone's working off the same core information.
Precisely. And this interoperability, as it's called, is crucial. Think about the old way. Manual data copying between different design disciplines, architectural, structural, mechanical, electrical, plumbing, MEP.
Sounds tedious and error-prone.
It was, and sources note it greatly discourages iteration during design because making changes was so cumbersome. It also inevitably leads to errors, which stifles innovation and complex problem solving. BIM aims to streamline this by allowing different teams to all work within or connect to the same integrated data set, minimizing errors and fostering much better collaboration.
That makes perfect sense for avoiding clashes like pipes running through beams and just ensuring everyone's literally on the same digital page. What does the future hold for this kind of digital integration in construction? Where is BIM heading?
Well, the BIM Handbook, a key resource in the field, speculates on a future involving smart automated transactions on BIM servers. The idea is that these systems could manage changes across different disciplines automatically.
Automatically.
Potentially, yes, augmenting or even replacing some of the manual updates currently needed for synchronization. Imagine resolving complex issues like that clash detection example almost instantaneously and automatically, using AI and sophisticated algorithms to find the optimal solution that works for all systems.
That's pretty wild to imagine a building model that almost helps design itself to avoid conflicts. Can you give us some specific real-world examples of how BIM is actually used today for communication and planning beyond just having a static 3D model?
Oh, certainly. BIM enables what are called 4D schedules. This isn't science fiction. It's linking the 3D model components directly to the project schedule activities.
So you can see it being built virtually.
Exactly. You get this graphically rich and animated representation of the planned construction sequence set against time. You can literally watch the building come together virtually week by week, which is incredibly powerful for identifying potential bottlenecks or logistical problems before they happen on the actual site.
And I think I read about 5D as well.
Right. BIM also supports 5D cost management capabilities. This means attributing resources, labor, materials, and their associated costs directly to the model elements. This allows for highly accurate model-based cost estimation and tracking throughout the project.
This really reveals how modern technology is fundamentally reshaping the design and construction process. It's making it more collaborative, definitely more precise, and much more predictive. And ultimately, you can see how this impacts the efficiency and cost-effectiveness of building, whether it's a huge commercial project or, that single-family home we keep coming back to. Hashtag Tro B. The science and craft of materials. Okay, so we've got this amazing digital model. Now it's time to talk about the actual physical stuff, the materials. And this isn't just about picking something that looks good or fits the budget, is it? The choice and application of building materials seems like this profound blend of, scientific understanding, historical tradition, and practical, hands-on craftsmanship.
Absolutely. It's all of those things. Each material, wood, concrete, steel, masonry, glass, has its own unique set of properties, its strengths, its weaknesses, its challenges. And the knowledge of how to work with them, how to get the best out of them, that's been foundational throughout human history.
We've been figuring this stuff out for millennia.
Literally. From ancient texts like George Agricola's De Re Metallica, which detailed mining and smelting processes for metals way back in the 16th century, to architectural histories discussing the specific use of marble versus volcanic andesite in ancient Pergamon. Humanity has always been deeply engaged with understanding and manipulating materials.
And you had specialized crafts emerge around these materials.
Definitely. Think about the medieval guilds, the joiners and wheelwrights, the coopers, carpenters, armorers, and masons. These illustrate the highly specialized material expertise and craft traditions that built everything from everyday objects to soaring cathedrals. Each guild held deep knowledge about its specific material.
That's a huge scope, from ancient metallurgy to medieval artisans. Let's bring it down to a more relatable scale again. What about a material like concrete? We use it so much today, it seems almost mundane. But what's the science and craft behind that?
Concrete, yeah. It seems so ubiquitous and simple, but it actually has a lot of nuance. It's consistency, which basically means the amount of water used in the mix significantly impacts its final crushing strength. Generally, less water means stronger, more durable concrete. That's the science part.
Okay, so the mix is critical. Where does the craft come in?
The craft comes into play during its installation, its placement and finishing. Think about pouring a concrete slab for a house foundation. It's this multi-step process. Placing the wet concrete, striking it off level, floating it to bring the fine particles and bleed water to the surface, and then, at just the right time, steel troweling it for a smooth, dense finish.
Timing sounds important.
Crucial. And throughout all this, workers must be incredibly careful to avoid penetrating the moisture barrier, usually a plastic sheet beneath the slab. One careless step with a shovel or a rake can create a pathway for moisture to wick up from the ground later, causing long-term problems inside the house. So it's this blend of precise mixed design, science, and skilled, careful, hands-on workcraft that's vital.
It sounds like a seemingly simple slab has more personality and complexity than I ever imagined. What about wood? That's such a foundational material for so many homes, especially in North America.
Wood is fascinating because its natural properties dictate so much of how we use it. The intricate grain patterns, like curly figure in maple or ribbon figure in mahogany, they aren't just for looks. They actually influence the wood's strength and how it behaves when you cut or shape it.
And moisture is key with wood, right?
Absolutely critical. Its moisture content drastically influences both its strength and its workability. Green wood, freshly cut, is generally easier to shape and bend, but dry wood is significantly stronger and more stable, less likely to warp or shrink after it's put in place.
And then there's the whole craft of framing a house with wood.
Right. Floor systems, wall systems, roof systems all require precise cuts, strong joinery techniques, and the correct types of connections and fasteners to ensure structural integrity. Even something like roofing involves selecting specific types of wood shingles, like red cedar or redwood, known for their durability, and knowing the proper techniques for laying them to shed water effectively for decades.
Okay, finally, what about metals? We might not think of them as much in the main structure of a typical single-family home, maybe, but they're crucial for fasteners, connectors, maybe some structural beams or specialized components.
Absolutely essential. Even back in the 19th century, you had engineers like the brilliant Isambard Kingdom Brunel experimenting with things like gunmetal, a bronze alloy, for his experimental gas engine, because he needed something that could withstand immense pressures like 1,500 pounds per square inch, far beyond what cast iron could handle at the time. This highlights that constant push for metallurgical innovation driven by specific needs.
And even simpler metals used today have specific properties builders need to know.
For sure. For instance, older handbooks detail the properties of cast iron columns, noting they were relatively inexpensive and actually resisted fire and corrosion better than steel, although they had limitations under certain types of loads, particularly eccentric loads. So understanding the specific strengths and weaknesses of different metals is vital for using them correctly and safely, even for the nails and screws holding everything together.
Ultimately, it seems, every brick, every 2x4, every pour of concrete is really a testament to centuries of trial, error, scientific discovery, and skilled mastery. It's not just material. It's a legacy of human ingenuity and skilled hands, shaped into the places we live and work. #TechAC. Building codes and best practices. So we've designed it digitally. We've chosen the perfect materials based on science and craft. But all this ingenious work needs a framework, doesn't it? A set of rules. What are the non-negotiables that govern every nail and beam, primarily aimed at ensuring safety, structural integrity, and performance?
That framework comes primarily from building codes and also evolving best practices. And you're right, they are absolutely non-negotiable. These set the minimum acceptable standards for construction.
And these codes are the same everywhere.
That's a key point. No, they're not. Building codes are typically based on model codes, but they're adopted and often amended at the state or local level. And importantly, as resources like Building Codes Illustrated emphasize, many jurisdictions have not adopted the latest versions of the model codes. So local familiarization is absolutely crucial for designers and builders. You have to know the rules where you are building.
Okay, so you need local knowledge. What are some of the key areas these codes typically cover?
They cover a vast range, but some critical areas include exits egress. This outlines things like the minimum number of exits required, maximum travel distances to an exit, and the capacity per occupant to ensure people can get out safely in an emergency.
Like a fire.
Exactly, which leads to fire resistance requirements. These specify things like how quickly materials allow flame to spread, how much smoke they generate, and the required fire protection for structural members, like beams and columns, to ensure the building remains standing long enough for evacuation.
Makes sense. What else?
And even things like ventilation. Codes have strict requirements for ventilating spaces like attics and crawl spaces, often specifying free area requirements for vents or mandating things like continuous ridge vents. This is crucial for preventing moisture buildup, which can lead to mold and structural decay.
So these codes are really like the unseen guardians of our safety and health when we're inside a building, ensuring fire safety, structural integrity, even air quality to some extent. But it's not just about immediate safety anymore, is it? There's this huge push for environmental performance now, too.
That's entirely correct. The rise of sustainable construction or green building has led to initiatives like the LEED certification system, leadership in energy and environmental design.
Right, you see those LED plaques on buildings sometimes.
Exactly. LEED assesses buildings across multiple categories, things like energy efficiency, water use, material selection, site impact, indoor environmental quality, and buildings can achieve certified silver, gold, or platinum ratings based on the points they earn.
So these certifications aren't just labels. They represent a comprehensive approach to minimizing a building's environmental footprint and maximizing occupant well-being.
That's the goal. These standards drive lower energy consumption through better insulation, efficient windows, and optimized systems. They also aim to enhance indoor environmental quality, or IEQ, through careful material selection, for example, using paints, adhesives, and flooring with low VOCs, which are volatile organic compounds that can off-gas and affect air quality, and through better lighting design and HVAC systems.
So these standards push beyond the basic safety net of the codes. Can you give some very practical examples of how these codes and maybe stricter climate-specific guides influence daily construction choices, perhaps specifically for building a home?
Certainly. Let's go back to that builder's guide for hot, dry, and mixed dry climates. It explicitly mandates, for instance, that mechanical equipment and ductwork should not be located in exterior walls, vented attics, vented crawl spaces, or garages in those climates.
Why not?
To prevent condensation problems caused by temperature differences and to avoid significant energy loss from ducts running through unconditioned spaces. The guide also stipulates things like wood-burning fireplaces or gas-burning fireplaces should be supplied with glass doors and exterior combustion air ducted to the firebox.
For safety.
Primarily safety, yes, preventing backdrafting of combustion gases into the house, but also for energy efficiency by not drawing heated indoor air up the chimney. These are very specific, almost mundane-sounding details, but they are entirely driven by code and best practice to ensure the long-term performance, safety, and efficiency of a home.
The insight here, for you listening, is that these codes and practices are the unseen guardians of your safety and comfort. They shape every aspect of a building's construction, from its foundational elements, literally, to the very air you breathe inside. They ensure resilience against both the slow creep of time and the suddenness of disaster. They are, in a way, a silent promise of integrity built into the structure. Now, let's turn to what is, for me at least, often the most fascinating part, the real beating heart of any building project, the human equation. Because as we mentioned right up front, a building is never just about materials and codes and blueprints. It's a deeply, sometimes messily human story.
It's so true. Construction is fundamentally a collaborative team activity, as the project management books say. But that team involves incredibly diverse specialists, architects, engineers, builders, subcontractors, suppliers, clients, inspectors.
A lot of cooks in the kitchen.
Potentially, yes. And often, it's their interactions, their personalities, their communication styles, their ability to trust each other and work together, not just their individual technical skills, that determine whether a project is a smooth success or, frankly, a nightmare.
And for this specific part of the discussion, we're going to really lean into Tracy Kidder's book, House, because it just captures this dynamic so brilliantly. It really feels like a microcosm of the entire construction industry played out on the very intimate scale of one family's dream to build their custom home.
What does Kidder show us about that interplay between the architect, the builder, and the client in this intensely personal process?
Kidder's book gives us this incredibly potent illustration, mainly through the character of Jim, the head builder on the project. Jim's described as being incredibly adept at his craft, at exterminating vagueness and confusion on the job site. He understands construction deeply, and he actually enjoys the financial aspects of running his business.
Okay, so he's competent, professional, very much so. But then, when his client, Jonathan, who is portrayed as well-meaning but perhaps a bit controlling or naive about the process, always has an opinion, even a seemingly minor financial disagreement, I think it was over just $660 for some extra work, can leave Jim feeling profoundly wounded.
Wounded. Not just annoyed, but wounded.
That's the word Kidder uses. Jim articulates this core tension he feels. The difference between hiring someone to do a job for you and hiring a job to be done. The first implies a sort of subservient relationship. The second, a partnership based on expertise and respect.
Oh, I see. That's a subtle but huge difference in perspective.
It really is. And this incident powerfully highlights the significant emotional labor involved in construction and the potential for conflict that completely transcends the purely technical specifications or the financial figures on an invoice. It becomes personal.
That's such a relatable feeling, isn't it? That shift in the tone of a relationship where suddenly it feels less like collaboration and more like something else. It sounds like the human element can be as important, or maybe even more important sometimes, than the structural integrity or the design details.
Absolutely. And this is reflected even in formal project management standards. They emphasize tailoring based on context, recognizing the unique objectives, environment, and crucially, stakeholders of each project. Project success, they say, hinges on adapting governance and processes to foster flexibility and produce positive outcomes. And critically, it emphasizes communication to navigate those diverse perspectives and potential conflict.
Jim's experience is like a perfect, painful, personal example of that conflict playing out when communication and trust maybe falter.
Exactly. And that dynamic where personal feelings and perceived disrespect can overshadow the actual technical work, it really underscores the value of things like constructability reviews that construction managers advocate for during the pre-design phase.
What's the goal of those reviews?
The goal is to have experienced builders evaluate the design documents early on, specifically for clarity, consistency, completeness, and ease of construction. The aim is to iron out potential ambiguities, conflicts, or overly difficult details before they become sources of misunderstanding and tension on site to prevent the kind of painful conflict that Jim experienced later in the project.
Trying to head off the problems before they start. Makes sense.
And Kidder also gives us this beautiful illustrative glimpse into the deeper human desires at play, how the builder connects the physical structure to the lives it will eventually contain. He describes Jim, the builder, sometimes imagining the clients, Jonathan and Judith, years later, gone gray, sitting there in rockers on the porch he built, or picturing Judith descending in the grand staircase in a party dress.
He's seeing the life in the house already.
Yes. His concluding thought, as Kidder relates it, is simply, a house lives. It beautifully encapsulates this integration of human aspiration, memory, and future life with the built environment. The physical structure becomes imbued with the meaning and the life it will hold, even during construction.
This human drama, then, unfolding between the client's aspirations, the architect's vision, and the builder's execution, mediated by budgets and personalities. That's the vibrant, sometimes difficult core of any building project. It illustrates that a house is lived in and imbued with meaning long, long before the moving trucks arrive. It's truly a story of relationships, built layer by human layer, right alongside the walls, #TAG-TAG-TAG-B, the value of craft and skilled labor.
Now, moving from those complex relational dynamics to the practical execution, but still keeping it deeply human, we absolutely must emphasize the irreplaceable value of craft and skilled labor. Despite all the technological advancements, all the digital tools, all the shift towards industrialization and prefabrication, true human skill remains absolutely central to quality construction.
Yeah, it's easy to forget that sometimes in our age of machines and, mass production, isn't it? We sometimes tend to glorify the design part, the conceptual part, and maybe inadvertently overlook the immense skill and intelligence involved in the actual making of things.
Exactly. The Industrial Revolution, as historians note, brought about a massive qualitative shift from the preceding craft era, moving from primarily handcrafted production to industrial mass production. That was a huge change.
But craft didn't disappear.
Not at all. And even in ancient times, highly specialized craft was absolutely crucial. Think of incredibly detailed instructions found in old texts, like Moxon's mechanic exercises from the 17th century, describing the precise filing needed for making type punches for printing presses to achieve the true fatness and perfect letter forms. This level of meticulous detail highlights the immense skill required for even seemingly small, repetitive tasks that demanded precision.
That's a great historical example. So even today, in our modern world, where does that skilled craft really come into play on a typical construction site? Isn't a lot of it mechanized or simplified now?
Well, some parts are, but much of it still relies heavily on skilled hands and experienced minds. There's sometimes this persistent cultural divide, as some writers like Matthew Crawford in Shop Class as Soulcraft imply, between design often perceived as purely cerebral And the act of making seen maybe as just sensual or manual.
A split between head and hands.
Kind of. And this can lead to overlooking the intrinsic value, the embedded intelligence, and the crucial problem-solving capabilities of those engaged in manual skilled work. This is reminiscent, again, of those cultural and class divides that surface subtly in Kidder's house. The difference in perspective and perhaps mutual understanding between the architect's world of abstract ideas and drawings and the builder's world of tangible execution, dealing with the messy reality of materials and site conditions.
So the trades aren't just blindly following instructions from the plans. They're constantly interpreting, adapting, and solving problems in real time on the job site.
Constantly. Think about it. Can you give us some specific examples of this kind of craftsmanship you'd find in the process of building a typical home?
Certainly. Consider intricate masonry work. Laying brick or stone requires not just strength, but a keen eye for alignment, consistent jointing, color blending, and ensuring proper weather resistance. Or think about the precise wood framing techniques we mentioned, understanding how to lay out walls perfectly square and plumb, cutting complex roof rafters, ensuring strong connections that will carry load safely for decades.
It's not just nailing wood together. Not at all. Even the multi-stage concrete finishing processes we discussed, knowing exactly when the concrete is ready for each step, achieving that smooth, durable surface requires immense learned skill, experience, and attention to detail. Every perfectly plumbed wall, every smoothly troweled concrete slab, every tightly fitted piece of trim is really a testament to years of practice skill and accumulated knowledge passed down through the trades.
This gives you, the listener, a powerful appreciation, hopefully, for the immense amount of craft, coordination, and, going back to Kidder, emotional labor that goes into transforming raw materials into a functional and beautiful home. It's a testament to generations of accumulated knowledge and skill quietly shaping the spaces we inhabit every day. #C. Communication, trust, and managing expectations. Okay, we've talked about the incredible craft involved, the skill of the hands. But tying it all together, or sometimes unfortunately pulling it all apart, is that crucial human element of communication and trust. It really feels like these are perhaps the single most critical best practices in construction. Absolutely vital for navigating the inherent complexity and hopefully avoiding costly disputes.
They are absolutely paramount. Project management guides emphasize that project team members and other stakeholders are the main sources of information regarding uncertainty. What does that mean? It means their open, honest, transparent communication is essential for identifying potential problems, assessing risks, and finding solutions before things go badly wrong.
So it's about creating an environment where people feel safe to speak up.
Exactly. A construction manager's role, for instance, is explicitly described in professional standards as involving generating cooperation and obtaining commitment from each contractor to meet the project objectives. It's not just about giving orders, it's about actively engaging all parties in developing the schedule, discussing potential issues, and updating everyone regularly. It's about building consensus and shared ownership.
So it's not just about sending emails or having meetings. It's about actively fostering an environment where everyone feels heard, valued, and genuinely committed to the shared goal. What are some of the daily challenges in this area on a real project, and how are they typically resolved, or maybe how should they be resolved?
Well, think about the general contractor's role on a typical project. They have to oversee and manage all of the construction operations into a single, safe, coordinated effort. How do they do that? Through constant, effective communication with dozens of different subcontractors, the plumber, the electrician, the drywaller, the painter, and also with their own field staff.
That sounds like a constant juggling act.
It is. It highlights the daily grind of aligning all these diverse parties, managing their expectations, making sure everyone has the information they need when they need it, and ensuring everyone is literally working off the same page, the same set of updated plans. Clear, timely communication is the only way to avoid costly errors, rework, or conflicts between trades.
And this brings us right back so powerfully to Kidder's house and Jim the Builder's experience, doesn't it? That $660 dispute wasn't fundamentally about the money itself.
Not at all. Not for Jim in that moment. Jim's resolution, or rather his reflection after his argument with the client, Jonathan, was incredibly telling. Kidder quotes him saying, "I don't want retribution. I want them to understand that they changed the tone of the job in my mind."
Wow. Change the tone of the job. That says so much.
It powerfully illustrates that conflicts in construction are rarely just about the money or the technical details. They are often deeply rooted in issues of trust, respect, and the perceived fairness of the working relationship. It reinforces that core idea from the book and from our discussion. we don't just build structures, we build relationships in the process.
That personal, emotional impact of a disagreement is precisely why, on larger, more complex projects, you have formalized procedures, like claims management. Construction managers establish specific methods and procedures designed to minimize the impact of claims through prompt and equitable resolution.
Trying to take the personal sting out of it.
Trying to, yes, by having a process. Often they discuss all claims and potential claims weekly at the progress meetings. These are direct attempts to institutionalize trust and communication, to create formal channels for resolving disagreements in what can often be, let's face it, an adversarial environment. They're trying to prevent those wounded feelings Jim experienced from festering and poisoning the whole project.
The key takeaway here, really, is that a successful construction project isn't merely a technical feat of engineering and logistics. It's profoundly a social triumph as well. The quality of the relationships built between the client, the designer, the builder, and all the subcontractors can be just as important, maybe even more important sometimes, than the quality of the physical structure itself. It's about finding that common ground, maintaining mutual respect even, or especially, when opinions inevitably differ and expectations clash.
Okay, so assuming those human dynamics are hopefully running relatively smoothly, the project moves into the really intense phase of execution, the actual building. And in construction, maybe more than in many other fields, time is this finite, precious, and often unforgiving resource, isn't it? It has to be meticulously managed through detailed schedules.
Indeed. Time is money, as they say, and delays can be incredibly costly. The whole process starts with figuring out, okay, how much time is each individual work activity realistically going to take? And then, crucially, determining how that work will be sequenced. What has to happen before something else can start?
The dependencies.
Exactly. This process of outlining activities, durations, and dependencies reveals what's known as the critical path. This is the specific sequence of activities that determines the earliest the project can possibly finish. If a single activity on that critical path gets delayed, the entire project completion date gets pushed back, unless you can make up time later. It's truly the lifeline of the project timeline.
I can only imagine how complex that critical path must get on a big project with hundreds, maybe even thousands of interconnected tasks. Are there advanced techniques to manage this complexity and truly optimize the workflow beyond just, say, a simple bar chart?
Oh, definitely. Project scheduling has become quite sophisticated. Planners use advanced concepts like different types of relationships between tasks. For example, a start-to-start SS relationship, often with a lag time, is common.
Start to start. What does that mean?
It means a successor activity, let's say, laying pipe in a trench, can begin a certain number of days after its predecessor activity, like excavating that trench, starts. You don't have to wait for the entire trench to be dug before you start laying pipe in the first section.
Ah, so you can overlap the work efficiently.
Precisely. This allows for concurrent work and optimizes workflow, avoiding potentially wasteful traditional solutions that might break a continuous operation, like trenching, into isolated segments just to fit a simpler schedule logic. It significantly improves both efficiency and the realism of the schedule on complex projects.
That sounds like a really sophisticated dance of dependencies and overlaps. The business management book, The Goal, offers a great simple analogy for this kind of challenge, doesn't it? Even though it's about manufacturing.
It does. It's surprisingly applicable. The goal illustrates the impact of dependent events, like construction tasks that rely on each other and statistical fluctuations. The fact that tasks rarely take exactly the predicted amount of time, using a simple hiking analogy.
The Boy Scout hike.
That's the one. Imagine a line of hikers on a narrow trail. The speed of the entire group, throughput, is dictated by the slowest person in the line, right? The bottleneck.
Right. Everyone piles up behind Herbie.
Exactly. And if earlier people in the line are slow for a bit, that slowness accumulates down the line. To catch up, the last person in line has to move faster than average for a distance equal to all the excess space between all the boys. This vividly explains the challenge of bottlenecks in any sequential process, like a production line or a construction sequence. One delayed trade can hold up an entire chain of subsequent activities, causing that ripple effect delay.
So it's not just about each individual worker or crew working as fast as possible. It's about managing the overall flow and identifying where the constraints are, where the bottleneck is in the whole system, and making sure that part keeps moving. What about day-to-day flexibility, though? What if something minor inevitably goes wrong, like a delivery is a bit late or it rains unexpectedly?
That's where the concept of float or slack comes in. Float refers to the amount of time and activity not on the critical path can be delayed without affecting the project's overall completion date.
So it's like built-in buffer time for some tasks.
Essentially, yes. It's an absolutely essential tool for site superintendents in managing the daily realities and unpredictability of a construction site. It allows them to adapt to minor delays, shuffle resources slightly, without necessarily impacting the critical path and the final deadline. It's the small buffer that allows for real-world adjustments.
This really demystifies that intricate logistical puzzle behind every construction timeline. It shows how small delays, especially on critical tasks, can cascade and have major impacts, and how understanding concepts like bottlenecks and float is absolutely crucial for keeping a project moving efficiently and hopefully meeting those all-important deadlines. Hashtag B budget and cost control.
And running right alongside time management, equally critical, is financial management. Budget and cost control in construction isn't a one-time thing, it's a continuous, evolving process. It requires careful estimation upfront, yes, but also constant monitoring, reporting, and adaptation throughout the project to maintain control over costs amid all the inherent uncertainties of building something unique.
So just like the schedule, a budget isn't just a fixed number that you set at the beginning and then magically stick to, is it? It sounds like it's much more dynamic, much more of a management tool.
Far from fixed, usually. A project budget actually evolves. It starts with the agreed-upon estimates for all the individual project activities and work packages. These are then aggregated into what's called a cost baseline, which represents the approved budget allocated over the project schedule.
Okay, the baseline. But you mentioned uncertainty.
Right. And that's crucial. Recognizing uncertainty is key. Early in the design phase, when the details are still quite general, experienced construction managers often recommend including a design contingency, maybe as high as 15 to 25% of the estimated cost.
That sounds like a lot.
It reflects the unknowns at the early stage. As the design gets more detailed, that contingency can usually be reduced. It's also essential to have a clear basis of estimate document right from the start. This document explicitly states all the assumptions made in the estimate, any clarifications, any specific exclusions, and it should also begin documenting potential financial risks and opportunities. It's about transparency.
So building in that contingency isn't padding. It's a realistic recognition that things will change, things will crop up, and it's about proactively planning how to manage those changes financially when they happen. When they do happen, when the scope changes or an unforeseen cost arises, how are those shifts typically managed on the financial side?
This brings us to the formal mechanisms for handling changes to scope and cost during construction. The most common one is the change order. This is defined as a formal, written agreement between the owner and contractor for any additions, deletions, or revisions to the original contract documents. And crucially, a change order typically adjusts both the contract price and the completion time.
So it's a formal amendment to the contract.
Exactly. Then you also have claims, which are a bit different. A claim is a more formal demand by one party, usually the contractor, seeking compensation or time extension under the terms of the contract, often due to perceived changes, delays, or disruptions caused by the other party. Both change orders and claims require meticulously documented procedures for their initiation, review, negotiation, and eventual approval or rejection. It's a very structured, often legalistic way to handle the inevitable shifts and disagreements that arise.
And this again brings us back so vividly to Kidder's anecdote from House, doesn't it? Jim, the builder's wounded feeling over that $660 dispute with Jonathan, the client. It wasn't just about a simple line item on an invoice.
That's exactly right. It perfectly highlights the deeply human element in these budgetary disagreements. It shows how a seemingly small financial discrepancy can get tangled up with feelings of fairness, respect, and trust, transforming it into a point of real personal tension. It's like a microcosm of the larger, more formalized change order and claims management processes we see on big projects, but played out with raw emotion. It just shows how critical transparent communication and that foundation of trust are in navigating these moments to preserve not just the budget, but the working relationship itself.
What's fascinating here, for you listening, is that you gain a deeper understanding of why project costs can fluctuate. It's not always poor planning, sometimes it's just reality intervening. And you see why a budget isn't a static fixed figure, but a dynamic management tool, constantly being used to balance unforeseen circumstances against the planned expenditures. It's a living document, constantly interacting with the unfolding reality of the project, just like the schedule, and just like the building itself eventually will. Hashtag Schmeyers. Quality and safety management.
Okay, last but certainly not least, in navigating the build phase. ensuring the absolute highest standards of quality and, even more importantly, uncompromising safety. These are truly non-negotiable imperatives throughout every single phase of any construction project. You just can't compromise here.
These really feel like the bedrock principles, don't they? The things you absolutely cannot cut corners on, no matter the pressure on time or budget. What does quality management specifically entail on a typical job site? How do you ensure the work is done right?
Well, the construction manager, if there is one acting as the owner's agent, often has a role in monitoring contractor compliance with the quality level expected for the project. They might develop procedures for monitoring the quality of work being performed, like inspections or testing protocols.
But who is ultimately responsible?
That's key. It's crucial to understand that the construction contractor themselves is ultimately and directly responsible for the quality control of their own work. They are the ones who need the internal processes to ensure their work meets the standards specified in the contract. Documents everything from the strength of the concrete mix to the straightness of the walls to the final paint finish.
Okay, so quality is about meeting the specs. What about safety? That seems like an even more immediate, ever-present concern on a busy, dynamic job site with heavy machinery, heights, trenches, and lots of different trades working in close proximity.
Safety protocols are incredibly extensive and need to be enforced rigorously day in, day out. Professional standards outline comprehensive safety measures. This typically includes having mandatory safety representatives on site, conducting daily inspections of all active construction activities, performing detailed job hazard analysis, or JHAs, for potentially critical or high-risk tasks to identify potential dangers and plan how to mitigate them before the work starts.
Proactive planning for safety.
Exactly. And holding regular safety coordination meetings or toolbox talks to communicate safety guidelines and expectations clearly to all parties on site is also standard practice. Crucially, if a construction manager observes an unsafe condition, they notify the contractor. And if that unsafe condition isn't corrected promptly, the owner usually has the power, through the contract, to issue a stop work order for that specific activity, or even the whole site in extreme cases. That's a truly powerful intervention used when necessary.
And beyond the contractor's own QC and the CM's oversight, aren't there also external checks to ensure these minimum standards, especially for safety and structural integrity, are being met?
Yes, absolutely. We mentioned building code inspections earlier in the context of codes themselves. These inspections by the local building department are a necessity at various key stages of construction foundation: framing, plumbing, electrical, insulation, final. These are required for most permitted construction projects and serve as that critical external verification step, ensuring that the work conforms to the locally adopted minimum quality and safety standards. They're the check that says, yes, this meets the baseline requirements for safe occupancy.
Can we look again at how some of the advanced tools we discussed, like BIM, are actually being used not just for design or scheduling, but specifically to enhance quality and safety during construction?
Certainly. The BIM handbook provides good examples here too. Those 4D CAD techniques linking the 3D model to the schedule can be used for incredibly detailed micro-planning of a construction operation. For instance, they describe simulating the complex erection sequence for the roof of an underground subway station.
How does that help safety?
By simulating it virtually first, the project team could ensure that not only the strict time limits, maybe only a 48-hour window when train traffic is suspended, could be met, but also that all the complex lifting operations and safety measures could be planned, visualized, and rehearsed virtually before any physical work began with real workers and real equipment in a high-risk environment. This kind of detailed pre-planning dramatically reduces the potential for errors, accidents, and delays during the actual execution.
This insight into the rigorous, multi-layered processes of quality assurance and safety management, from the contractor's own responsibility to the CM's oversight to mandatory inspections to advanced planning tools, it really should instill confidence. It shows the layers of diligence and protection embedded in every properly managed construction project, looking after everything from long-term structural integrity to the immediate well-being of every worker on site. It ensures the building is not just functional and meets the design intent, but that it's built safely and built to last. Okay, so finally the building is done. The construction crews pack up, the keys are handed over, the client moves in, the last piece of trim is perfectly in place. But a building isn't just a static object at that point, is it? It feels more like a dynamic system that continues to interact with its users, its environment, its own internal systems, long after the builders leave.
That's a really critical point, and one that's often overlooked in the focus on just getting the project built. A building absolutely requires adaptability and ongoing care throughout its entire life cycle, which could be 50, 100 years or more.
So the project isn't really over at handover.
Not in a functional sense. Remember how we said that even during the project, the desired outcomes should be clearly described, iteratively assessed, and updated? Well, that principle extends well beyond physical completion. Buildings need to continue delivering their intended outcomes: shelter, comfort, functionality, efficiency. And sometimes the original business case is updated to capture an opportunity or minimize a problem identified by the project team and other stakeholders, even years after a building is occupied, leading to renovations or system upgrades.
So the performance of a building is this ongoing dialogue between the structure and its occupants and environment, not just a one-time assessment at completion. What happens practically after handover to ensure it continues to perform well and meet those potentially evolving needs?
Well, a crucial step, especially for complex buildings, is the implementation of commissioning plans. Commissioning is a systematic process designed to verify, document, and optimize the performance of building systems, HVAC, lighting, controls, to ensure they are actually functioning as intended according to the design after handover.
Making sure it works as designed in the real world.
Exactly. Beyond that initial check, the ongoing operations and maintenance phase is key to good long-term IEQ, or indoor environmental quality. This requires facilities managers and even homeowners to be aware of best practices for operating systems efficiently and maintaining materials properly to retain that environmental quality over time.
And looking further ahead, what's the future of building performance?
Well, some thinkers are exploring the concept of living with a home, where architecture becomes more of an active interface between humans, the environment, and networked infrastructure. This suggests a future of more dynamic, perhaps even learning spaces that can adapt automatically or with user input to changing needs, energy prices, or environmental conditions. Think smart homes, but potentially much more integrated and responsive.
That's a powerful vision, a home that almost learns and adapts with you over its lifetime. But what about its lasting cultural or aesthetic impact? Beyond just functional performance, how do we measure that kind of longevity? How does a building endure?
That's a much harder question, touching on aesthetics, culture, and relevance. Rainer Banham, a very influential architectural critic, famously posed a philosophical question when he was evaluating the New Brutalism architectural movement.
Okay.
He asked essentially whether its buildings talk across time to the great masters of architecture, or whether they only talk to each other, meaning are they part of a longer tradition or just a fleeting internal dialogue?
So does it have lasting relevance, or is it just a stylistic fad?
Exactly. It's a profound question that illustrates the ongoing dialogue about architectural relevance and longevity. What truly makes a building endure, adapt functionally, and continue to inspire or hold meaning for generations, rather than simply fading into obsolescence or being torn down? There's no easy answer to that.
This perspective really invites you, the listener, to see buildings not merely as finished products, static objects frozen at the moment of completion, but as active participants in our lives and environment, requiring continuous engagement, maintenance, adaptation, and maybe even conversation to truly thrive over their long lives. #B. The societal and cultural footprint of architecture.
And broadening the view even further, beyond an individual building's performance or longevity, buildings collectively are incredibly powerful reflections of human society. They shape our cultures, our communities, our economies, and our collective experiences in profound ways, embodying both our grandest aspirations and our most mundane, everyday realities.
I immediately think of some iconic historical structures, like Europe's great Gothic cathedrals. They were obviously places of worship, but they served much broader roles in their communities, didn't they?
Oh, absolutely. Historical accounts make it clear that Gothic cathedrals, beyond their primary spiritual function, were truly community centers as much as they were halls of faith. They often hosted town meetings, served as venues for courts of law, and even staged theatrical and musical performances. They were integral hubs of civic, social, and economic life, physically dominating the medieval townscape.
So architecture actively shaped medieval society. What about the other way around? Can urban design hinder community?
Definitely. Think about the critiques of certain 20th century urban planning approaches. Jane Jacobs, in her seminal book, The Death and Life of Great American Cities, argued passionately that city neighborhoods need to supply some means for civilized self-government, and that intricate mixtures of buildings, uses, and scenes are necessary for successful city districts to foster healthy urban life. She decried large-scale single-use developments that she believed destroyed the fine-grained social fabric of vibrant neighborhoods. Her work emphasized the profound impact of physical design on daily human interaction, safety, and community vitality.
This really speaks to the immense, sometimes overlooked, power of architecture and urban planning, how it can shape not just aesthetics, but democracy, community health, and social equity. What about individual figures who wielded this power on a massive scale, like Robert Moses in New York City?
Robert Moses is a fascinating and controversial example. As depicted in Robert Caro's epic biography, The Power Broker, Moses wielded almost unprecedented influence through his vast public works projects, bridges, highways, parks, public housing. Caro argues he shaped the character of the city as profoundly as any individual in modern times. His ability to amass power, secure funding, and push through enormous construction projects, often despite fierce opposition and significant social costs, highlights the deep political, social, and economic dimensions of large-scale building. It shows how a single, powerful vision, backed by political will, can literally reshape an entire metropolitan region for generations.
For better or for worse sometimes.
Often a mix, yes. And what about that connection we touched on earlier between the act of making, the craft involved in building, and maybe human identity or well-being?
Right, that idea from shop class is soulcraft.
Exactly. Works like that imply there's a deep, perhaps undervalued connection between human identity and engaging in productive, skilled work with tangible results. This suggests that well-crafted environments, spaces built with care, skill, and attention to human needs, might actually imbue a sense of meaning, purpose, and dignity, impacting the psychological well-being of both the builders and the inhabitants. When a building is well-made, functional, and maybe even beautiful, it seems to reflect and reinforce positive human values, contributing to a stronger sense of place, community, and belonging.
It seems every structure, then, from the humblest dwelling made with local materials and traditional skills to the most monumental civic building expressing collective aspirations, tells a rich story. A story about its creators, its intended purpose, the technology of its time, and the values of the society that brought it into being. Architecture really is a profound mirror, reflecting both the best and sometimes the worst of human values and societal structures. #C, the human element of legacy and continuous improvement.
And finally, bringing it all together, we arrive at the legacy of all this immense effort. The legacy of the building, yes, but also the legacy of the process. The pursuit of excellence in construction and architecture and engineering, it's an ongoing human endeavor. It's characterized by continuous learning from both successes and failures, by constant problem solving, and, maybe most importantly, by the lasting impact of the human relationships forged or broken during the intense crucible of the build.
It sounds like it's never really a finished process, even intellectually or professionally, after the last coat of paint dries. There's always more to learn for the next project.
That's absolutely right. Think back to that business principle from The Goal we mentioned regarding bottlenecks. The protagonist realizes that finding effective solutions often requires digging deeper, using more scientific techniques, and sometimes having the courage to break all the rules when conventional approaches clearly aren't working.
A mindset of continuous improvement.
Exactly. It emphasizes a mindset of continuous improvement and adaptation, not just in manufacturing, but in project management and construction, too. The ability to apply not just rules, but logic and the reason behind the methodology allows for continuous adaptation and learning because, let's face it, no two construction projects are ever truly identical. Unforeseen challenges are always part of the journey, and the ability to learn and adjust is critical.
This raises an important point about the role of the engineer, the architect, the builder, any technical professional involved in this process. It seems it's not just about technical skill or mastery, is it?
No, and Samuel Florman, an engineer who wrote eloquently about his profession in The Existential Pleasures of Engineering, argued strongly for this. He believed engineers needed to be sensitized and liberally educated to strive to understand the imperfections and the absurdities of his fellow human beings.
A humanistic understanding.
Yes. He suggested that technical mastery, while essential, must be combined with this deep humanistic understanding and awareness of history, society, ethics, and the complexities of human nature to truly ennoble the profession and allow it to contribute meaningfully to improving society. It's about building not just structures, but building with a conscious awareness of the human condition, not just blindly following blueprints and calculations.
And this brings us back one last time to that incredibly powerful, simple insight from Tracy Kidder's house. Jim, the builder, after that painful conflict with his client over the $660, didn't want retribution. He didn't just want his money. What did he want?
He wanted them to understand that they changed the tone of the job, in my mind.
That quote just resonates so much.
That simple statement speaks volumes, doesn't it? About the profound and lasting impact of interpersonal dynamics, of communication, of trust, on project outcomes, and on the people involved. It powerfully reinforces the idea that has run through our entire discussion today. In construction, we don't just build structures, we build relationships. And the quality, the health, the resilience of those relationships, whether they are harmonious and collaborative or fraught with conflict and mistrust, leave a legacy right alongside and sometimes long after the physical building itself.
This really reminds you, the listener, that construction is fundamentally an iterative process of building, yes, but also of learning, of problem solving, and of deeply personal, sometimes challenging human interaction. And the quality of those relationships often mirrors and influences the quality of the final structure, leaving a legacy that extends far beyond just the physical form standing on the site. #tag outro. And that, deep divers, brings us toward the end of our journey today. We've really tried to peel back the layers of building construction, moving beyond just the visible structures, the walls, the roof, the finishes, to uncover that intricate, fascinating dance of planning, design, materials, technology, and maybe most critically of all, human collaboration.
Yeah, we've seen that every beam, every concrete pour, every wall, every window placement, every single design choice is really a testament to countless decisions, endless negotiations, unforeseen problems solved, and the forging or sometimes the straining of human relationships. Sometimes those relationships are harmonious, sometimes they're really challenging.
The essential insight, I think, from this deep dive, especially illuminated by Kidder's house, is that a building project, at its very core, is a profoundly human story. It's this complex dialogue, isn't it?
Yeah.
Between a client's aspirational vision, what they dream of, an architect's creative ingenuity, how to make it real and maybe beautiful, and a builder's skilled craft and practical knowledge, how to actually get it built well.
And that dialogue is constantly mediated by communication or lack thereof, by budgets, by schedules, by regulations, by unforeseen site conditions, by personality clashes, and sometimes just by the sheer force of human will needed to push through the difficulties. It's the story of how cultural divides, different assumptions, and personal feelings can really shape the very spaces we end up inhabiting.
So here's a final thought for you. The next time you step into any constructed space, whether it's your own home, your office, a public library, a restaurant, or even a grand historical monument, take just a moment. Consider not just its aesthetics or its function, but try to imagine that invisible network of relationships, the skills applied, the challenges overcome, the conflicts resolved or maybe not resolved, and the immense amount of cognitive and emotional labor that collectively brought that space into being.
What unspoken stories do its walls hold about the people who dreamed it, designed it, and built it? And what does it truly reveal, if you look closely enough, about that complex, perennial human dance between vision, craft, money, and relationships in our world?
Some things to ponder. Thank you for joining us on the Deep Dive.
We hope you look at the built world around you with new, maybe more appreciative, and definitely more curious eyes.